Imagine a machine that organizes your cupboard exactly how you like it, or serves everyone a customized cup of coffee to start their day. This automation extends to your smartphone, your social media feed, and your car's navigation system. In these moments, technology works so smoothly that it becomes an invisible part of the daily routine. Because these tools respond so intuitively to our needs, the underlying mechanics often go unnoticed. Behind the convenience, these systems are operating entirely on a foundation of algorithms and mathematical functions. If the brain of the machine is built on math, what specific behaviors allow it to cross the threshold into what we call intelligence? To find the answer, we have to look past the hardware and examine the logic used to navigate an unpredictable world. Take a robot designed in a lab and drop it into an open field. To function, it must process a sudden influx of data regarding lighting, terrain, and the physical dimensions of its environment. When the robot adjusts its movements to account for these shifting external conditions, it is practicing generalized learning, the ability to react appropriately to a new situation. At a fork in the road, the robot encounters one path that is paved and another that is rocky. It evaluates the circumstances of each route and selects the one that allows for the most efficient travel. Finally, the robot reaches a stream it cannot swim across. Using a provided input, the robot positions a plank to bridge the gap. It has identified a specific obstacle and generated a viable solution to overcome it. These three capabilities, adaptation, evaluation, and generating solutions, collectively define a machine as artificially intelligent. Despite these abilities, the technology we use today is classified as weak or narrow AI. Consider AlphaGo. It is a maestro of the game Go, yet it cannot play a single round of chess. It is a specialist, confined to a single domain. Even the smart speakers in our homes follow this rigid structure. When you ask it to play a song, it scans for keywords and runs a pre-trained program. If you ask a question outside of its training, like the specific traffic status of your commute, it cannot provide an answer. To understand how we move from keywords to complex behavior, we have to look at how these systems are layered. Artificial intelligence is the broadest category. Nested within is machine learning, which learns from data through algorithms. Deep learning is the innermost subset, using brain-inspired methods to perceive complex patterns. This layered structure of data processing creates a specialized tool, allowing for sophisticated outputs without requiring the machine to possess an independent mind. That concept of an independent mind is strong AI. This is the realm of fiction, exemplified by characters like Ultron, machines that are self-aware, unpredictable, and capable of developing their own emotions. While strong AI doesn't exist yet, the maturation of deep learning is beginning to bridge the gap between fiction and reality. Futurist Ray Kurzweil predicts that by 2045, we will reach the singularity, the point where robotic intelligence becomes indistinguishable from human intelligence. Elon Musk suggests a different path, predicting that humans will eventually use AI implants to enhance our own minds and bodies, merging with the technology we created. Because the human brain remains a mystery, there are still domains of consciousness and creativity that AI has not yet entered. Consider our current progress and ask yourself, which of these milestones has not yet been achieved yet? An AI robot with citizenship, a robot with a musculoskeletal system, AI that reads its owner's emotions, or an AI that develops its own emotions over time. As the technology matures, the definition of what a machine can think will continue to evolve. For now, AI remains a mathematical tool built to extend the reach of human capability.